Okay, now we're going to go on to simplifying numbers 11 through 22. So number 11, we have 64 to the 2/3. If it helps, you can write it in radical notation. And just so as a little review, roots go on the outside, and the roots are always on the bottom. So this is technically the cube root of 64, and then we're going to square it. You can write the square inside or outside that radical. But technically, you're taking the cube root of 64 first, especially if you will not have a calculator for this portion of it. So 64, some of you already know what the cube root is. I'm just going to break it down just in case you've forgotten. It's 4 times 16. 16 breaks down to 4 times 4. So basically the cube root, you're looking for 3 of a kind, the cube root of 64 is 4. But you're not done because you still have to square it, and 4 squared is 16. Okay? And so if you don't want to rewrite this here, you could do the mental math and say the cube root of 64, oh, I know is 4, and then I still square it. That's how I'm going to do the next one. Okay? So number 12 is 81 to the 3/4 power. So I'm going to take the 4th root of 81 first. Instead of rewriting it, I'm just going to go through it. So the 4th root of 81 is 3, but you still have to cube it, which gets you 27. Okay? You could break down the 81 and look for 4 of a kind if it helps. So you'll get 9, 9, and then the 2 9s will get you your 4 3s. All right, when you have a negative exponent, like number 13, you're going to have to do some flipping. 4 to the negative 1/2. So I'm going to go ahead and take the square root of 4 first. The square root of 4 is 2, but now you still have to raise that to the negative 1 power. And a negative exponent basically will flip it. 2 to the first is 2, and if you flip that, you get 1/2. All right, and then this one right here, 1 over 25 to the 1, oh wait, that's a negative 1/2. So I'm going to actually flip it. Sometimes it's easier for me. You could leave it like this and just do the square root and then flip it. A lot of you guys can do it mentally. But that negative exponent flips things, and now it becomes positive. And the 1/2 power, same thing as saying the square root. And the square root of 25 is just 5. Number 15. More of these simple ones. 125 to the negative, there's the negative again, 2/3. The cube root of 125 is 5, and then when you raise it to the negative 2 power, you square it first, which is 25, and then flip it, 1 over 25. All right, now we're getting a little bit more tricky. So when you have these rational exponents, you have 2 things you should ask yourself. Does it have the same base or the same root? And it has the same root here, same exponent. So I'm going to put the bases together. So the base I'm putting together is 12 divided by 4. 12 divided by 4 is 3. The 1/3 exponent didn't go away, and you still have the 2 on the outside. So now at that point, what I'm going to do is I'm going to go ahead and just multiply these exponents. You multiply them when they're next to each other. So you could visually look at it, it's over 1. So you have 3 to the 1 times 2 is 2, and 3 times 1 is 3. And you cannot take the cube root of 3. So that's, you can't do anything with it. And then number 17. So you have a square root, xy, then you have a 4th root, x squared y, and then just xy. All right, so in looking at this problem right here, you have the bases right here are not all the same. You do have x's and y's. You have a square root right here, and that's a 4th root, so those aren't the same either. So in order to get these all to be together, there's more than one way to do this problem. I'm actually going to change these to have a fraction in the exponent so I can kind of put them together. Because when they're like this, you can't put them together. But if I write x, the square root of x is x to the 1/2, and now I have just x here to the first, you can put things together. So the y is also to the 1/2 power. X is to the 2 over 4. That's a fraction, 2 over 4. 2 over 4 actually reduces to 1/2. And then y is going to be 1 over 4 power. and then it's just x to the fourth and y to the first on the bottom. I'm going to get the top together. So remember, you add exponents here. 1/2 plus 1/2 is 1. 1/2 plus 1/4. You need to get a common denominator, so I'm going to multiply the top and bottom of this one by 2 so you can have a common denominator of 4. So this gets you 2 plus 1, so that's 3/4 over just the xy. All right, at this point, I have x to the first on top and x to the first on bottom. That actually cancels. Keep in mind the exponent of y is 1. So you have the option of bringing the 1 up, the y to the first up, which would make that a -1 power, or bring y to the 3/4 down, and that'll make the 3/4 a negative exponent on the bottom. I'm purposely moving this to the bottom because 1 is a greater exponent, and I don't want negative exponents at the end. So I'm going to change this y to the 3/4 to go down below. Once you put it down below, it's going to change the exponent to be opposite sign. So this is y to the first. This is y to the -3/4. Okay. And so then what I'm going to do now is simplify. You have to add the exponents here. So I'm going to put this over 1. Common denominator is 4, so I'm going to multiply top and bottom by 4. It's a little bit big. So then you have 4 minus 3, which is 1, over 4. So you can write it like this, or you can write it as the 4th root. But it needs a positive exponent to be considered simplified. Okay, number 18. So you have x to the 1/3 over x squared all to the 1/4 power. Does it have the same base or the same exponent? It has the same base. So we're going to put the exponents together. So you have two options for putting the exponents together. I could take these two right here and actually subtract them. I could bring either the 2 up by making a -2 exponent, or the 1/3 down, making that negative. And then I still have to shower the power with that 1/4. Or I can actually shower the power with the 1/4 first. I'm going to work in the inside first here. So first of all, what I'm going to do is I'm going to see which one has the higher exponent. It's a higher exponent on the bottom, so I'm going to bring the 1/3 down. So I have x squared, and now it's x to the -1/3. That's a 1/3, by the way. Okay. And then I have to add the exponent. So I need a common denominator. I'll go ahead and put a 1 underneath here, which the common denominator between 1 and 3 is 3. So I'll multiply this by 3. I'm actually going to rewrite this because my pen's a little bit fat. It might be hard for you to see. So it's x, 2 times 3 is 6 over 3. And then this is still x to the -1 over 3. So let's put that together. Oh, and by the way, all of this I should have had to the 1/4 power because that didn't go away yet. All right, on the bottom, so we have to add these exponents. 6 minus 1 is 5, so I have 5/3. And then this is all still raised to the 1/4 power. And now I'm going to shower the power. 1 to the 1/4 power is just 1. And then remember, you multiply these. So if I multiply, it's across the top, across the bottom. 5 times 1 is 5, and 3 times 4 is 12. That's just one way to do that problem. Okay. And then number 19. If I have another paper. Okay, number 19, we have x to the 1/2, y to the 3/2. We have y squared all to the 1/4 power. Anytime you have fractions and you have parentheses, you should get rid of those parentheses first so you can put the individual parts together. So I have x to the 1/2, y to the 3/2, and on the bottom you have to multiply these together. So I'm going to put this over 1. You can multiply across the top and then across the bottom, or cross cancel. I'll cross cancel. 2 goes into 4 2 times. So this is really y to the 1/2 on the bottom. All right, so if you look at this, we have y's on top, y's on bottom. Those we have to get together. We actually cannot do anything with this x to the 1/2 power. So I'm going to leave that alone. And since 3 over 2 is more than 1 over 2, I'm going to move that up to the top. y to the 3 halves, and then y, because I'm moving this to the top, is a negative 1 half. And now putting these exponents together, they already have a common denominator. 3 minus 1 is 2. But 2 over 2 is just 1. So it's x to the 1 half and then just y. You don't even need to write the 1. It's automatically known to be 1. All right, and then number 20. Let me go ahead and pause this real quick. Okay, so on number 20, we have the cube root of 1,000 x to the 7th. So break down your 1,000. You're looking for 3 of a kind. That's basically 10 times 100. 100 is 10 times 10. So we have actually 3 tens here. So that's exactly 10. Now we're going to break down this 7. How many sets of 3 are there in 7? 3 goes into 7 2 times. 3 goes into 7 2 times. That gets you 6, but you have 1 left over. So that leftover has to stay inside as x, and don't forget the little tiny 3 because that makes a difference. It is a cube root. All right, number 21, they all have the same base, but we have to actually put these exponents together. And you cannot just simply add the exponents as they are. You have to rewrite those in rational exponents. So it's 10 to the 1 half. Remember, there's no number there. It's a square root. 10 to the 1/3, and 10 to the 1/6. So common denominator between 2, 3, and 6 is 6. So I'm going to multiply this one, top and bottom, by 2 to get a common denominator, multiplying this by 3. So I have 10 to the 3/6, 10 to the 2/6, and 10 to the 1/6. 3 plus 2 is 5, plus 1 is 6. So 6 over 6 just gets you 1. So 10 to the 1st is just 10. And then number 22. So number 22, we have the square root of 6, the square root of 24, and the square root of 2. All right, you have to ask yourself, does it have the same radical or the same base? And it has the same radical, so we could put all the bases together. You could kind of think of it as going 6 times 24 all over 2. Now you can multiply 6 times 24 together, but that's like extra work for me. I'm just going to take the 2 and reduce it, and then I'm going to break that down. 6 times 12 is in there. And you can multiply 6 times 12 and get 72 and break it apart, but then you're breaking it apart to 6 and 12 again. So I'm just going to break this down. 2 and 3, 4 and 3, 2 and 2. So I have a pair of 2's and a pair of 3's. So 3 times 2 is 6 on the outside, with this 2 right here left over. And